Hi everyone, so this is Unit 2, Lesson 2. We're going to be looking at how to find the length of a line segment using the distance formula. So there's this really short one. There's only two things you got to do here. You have to explain the connection between the distance formula and the Pythagorean theorem, and you have to figure out, once you know this formula, how do you use it to get the length of a line segment. Pretty simple. Okay, so we're going to look at example 1. We have 2 points on a graph, here and here. P and Q, and we want to find how far is it between them. So what is the actual distance between them? So I'm going to go over how you would do this without a formula to start, how you can just use what you know to get the formula, and then we're going to actually solve the problem. Okay, so what you can see then is if we have these 2 points, you can, what would you want to do if you wanted to calculate the slope of a line segment connecting them? So suppose these 2 points were connected with a line segment, and you want to find the slope. How would you find the slope? Well, if you remember from grade 9 or from, we've kind of used it before in this class, you would need the formula m equals to rise over run. And so you could even kind of draw on this graph how much you're going over, what your run is, and how much you're going up, what your rise is. And so you might get a picture that looks like this. So you start from this point. To get to this point, you have to go run over here along your x, and then rise over here along your y. So that's the formula, right? Pretty basic, m equals rise over run. But you know a different version of this formula. You also know that this formula works as m equals y2 minus y1 over x2 minus x1. And if the numerator is rise, and the numerator is also y2 minus y1, if you can think about the ideas behind substitution, then the rise will be equal to y2 minus y1, right? The rise will equal y2 minus y1. And that kind of makes sense when you think about it, because if at the bottom here your y value is 1, and then you're going up to a y value of 4, well, to get from 1 to 4, you have to add 3, right? You have to add 3, which is just 4 minus 1. So the distance that you're going up is the top number minus the bottom number. Your top y value of 4 minus your bottom y value of 1 will give you the difference between these 2 points, right? Same thing applies for the x values if you're looking at the run. So your run is the denominator here. If we look at our formula, the run is the bottom, and this is the bottom. So by substitution, these two are equal. So the run will equal to x2 minus x1. And again, that kind of makes sense. If you're going from 2 all the way over to 6, then the distance between here is going to be 4. Right, 6 minus 2, so there'll be a distance of 4 there. Okay, so what you might have noticed, and what I've kind of neglected to mention, even though it's right over here, is that when you draw this picture, this is actually a right triangle, right? That's a 90-degree angle there, even though I'm not showing it. And so what you have here is a 90-degree triangle with an A and a B, and normally we would call this C, but I'm going to call this D because this is distance. And we know by Pythagorean theorem that if this is a right angled triangle, then a squared plus b squared equals to d squared. But we said that a is the run, and we said that b is the rise between these 2 points. So what that means then is that if d squared is equal to a squared plus b squared, d squared will equal to rise squared plus run squared, right? A is just the run, so you just put well, I've kind of done this backwards. You can see the addition doesn't really matter. So I'm actually going to change this just so it actually makes more sense according to how it's written. Okay, so we have run squared plus rise squared. Okay, so the bottom A, which is your run squared, plus your rise squared, which is B, gives you d squared. Okay, so we're almost there. But let's just think about what run is, right? Run is x2 minus x1. And what is rise? Rise is y2 minus y1. So you can say that d squared is equal to, again, I'm going to put this in the right order. The run squared, which is x2 minus x1 squared, plus the rise squared, which is y2 minus y1 squared, right? That's just run squared plus rise squared. Run is x2 minus y1, x2 minus x1, rise is y2 minus y1. So I just plug those in by substitution. Notice that this is squared, so if I want to actually figure out what d is by itself, I would have to take the square root. So I take the square root of the left side to get d, and I take the square root of the right side, and I get this formula. So again, I'm going to move this over here to be consistent, but if you want to use this version of the formula, it will work just as well. It's not any different, really. So there we are. And I'll do the same thing here. Whoops. Okay, so that is our distance formula. All right, and that's what we're going to be using to solve the problems. So you'll notice, okay, I've got this example here. I haven't even put in any numbers. I haven't solved anything yet. All I've done is figured out this formula that we can now use to solve the problem quickly. So let's look back at the numbers again and what we were doing here. So we want to find the distance between 2 points, 2, 1, and 6, 4. So what I need to do is use this formula. So let me put this in here. There we are. Okay, so we've got x squared minus x2 minus x1 squared plus y2 minus y1 squared. I'm going to redo these numbers, which is actually not a bad idea because it's kind of good just to see that anyway. So x2, if I'm going to consider this x2 and y2, and this is x1 and y1, so x2 would be 6, and x1 would be 2, right? So that's our first x value. Y2 is going to be 4, and x2 is going to be 1. So that's going to reverse this, so I'm going to get 6 minus 2 is 4, and 4 minus 1 is 3. So that's going to give me 16 plus 9, which is going to give me 25. Take the square root, 5. So the distance between these 2 points is 5 units. I didn't specify if this is meters or anything like that, so we can just say that this is 5 units long. So the line segment PQ is 5 units. So pretty easy, right? If we go back to your learning goals, you do have to understand how this formula comes about, right? It's not magic. It's just the Pythagorean theorem mixed with understanding what rise and run is. So that's where this comes from. So you'll have to know where this comes from and then just how to apply it. So again, it's pretty easy to apply. The one thing you want to keep in mind is just like slope, just be careful about where you put your x2, your x1, your y2, and your y1 because they have to match up. So just be very careful with that. But beyond that, just a simple calculation. I've just done one example here. If you want to see another couple of examples, please watch this video. Okay, that's it. Thank you.